This problem is also based on the Newton's laws. After a mishap, a 76 kg circus performer clings to a trapeze, which is being pulled to the side by another circus artist, as shown here. Calculate the tension in the two ropes if the person is momentarily motionless. Include a free body diagram in your solution. Here is the free body diagram. Here is the circus performer. And then what happened? The lady is clinging to the cable. Okay. Another colleague of her is trying to balance her. Momentarily, the system is in static equilibrium. Okay. Motionless means a static equilibrium. He gave the angles. This angle as 15 degrees. And then another angle, this angle is 10 degrees. Now from the geometry of the figure, we have to make out the remaining angles. So the total angle, this is 90 degrees. So this is 75. That means remaining 75 degrees. 90 minus 15 is equal to 75 degrees. This angle is 15 given here. Okay, this is 15. 90 minus 15 is equal to 75 because the entire this angle is 90 degrees. As this is 75 degrees, this will also become 75. Okay. And then next, this is given as 10 degrees. Obviously, this will become 10. Okay. Now, the weight of the person acts vertically downwards. Her weight is, he gave 76 kilos as her mass. So, W is equal to 76 times 9.8. It gives rise to 744.8. That is equal to 745 newtons. Okay. Now the cables are making an angle. We have to resolve the tension into components, X component and Y component. So X component of T1 is equal to T1X, and then Y component of T1 is T1Y, acting vertically upwards. This is acting left side. Now resolve the T2 also into two components, vertical component and horizontal component. The horizontal component of tension T2 is T2X, and then vertical component is T2Y. Now I will write it. T2X is equal to, this is the angle, no? T2 cos 10 degrees. Adjacent side. Okay. Here this is T1 cos 75 degrees. Similarly, T2Y is equal to opposite side, no? T2 sine 10 degrees. Now T1 is equal to, T1Y is equal to T1 sine 75 degrees. Okay. Now we have to write the equations of for the static equilibrium. So horizontal component of forces, what are the horizontal component of forces? They must be equal to 0. Sigma Fx must be equal to 0. Net force along the X direction must be equal to 0. Sigma Fx is equal to 0. So T1x is equal to T2x because T1x is acting towards left and T1x is acting towards right. Therefore, T1x is equal to T2x. Therefore, T1 cos 75 is equal to T2 cos 10. Therefore, T1 is equal to T2 cos 10 divided by cos 75. It is equal to how much it is? 3.8 T2. Now we will write the vertical component of forces. T1y and T2y are acting vertically upwards and then weight is acting vertically downwards. Therefore, T1 sine T1y plus T2y is equal to sigma Fi is equal to 0 because the object is in static equilibrium. Sigma Fi is equal to 0. T1y plus T2y is equal to W. T1y is T1. Sine 75 plus T2 sine 10 is equal to 744.8. But T1 is equal to 3.8 T2. Therefore, T2 is equal to 744.8 divided by 3.8 sine 75 plus sine 10. That gives T2 is equal to, what is the answer for this? One 93.5. 1 second. 193.5. Okay. And then T1 is equal to 3.8 T2. So that is equal to 3.8 times 193.5. It is equal to 735.3 newtons. Or these are the values. This is 745 is the weight. And then T2 is 193.5, or you can write T2 is equal to 194. And then this as T1 is equal to 735. Because this is less than 5, we can take it as 735 newtons. This is 745 newtons. Okay. Thank you. Bye-bye.